Okay, we're going to be doing integration by substitutions. Now, there's quite a few of these integration by substitutions, but the first one we're going to do is undoing the chain rule. Okay, so look at this example here that we were differentiated. If you differentiate 3x squared plus 5x to the power 10, you use the chain rule. You put the 10 in front, you reduce the power by 1, you get 9. And then you have to differentiate the 3x squared plus 5x to get 6x plus 5. Okay. Now we are going to be doing integrals that look like this, where we're going backwards. What did I differentiate to get that? Okay, so I've got this that highlighted bit here. Let's integrate this. Okay, so we can see that someone's used the chain rule because I can see that the 6x plus 5 is the derivative of the 3x squared plus 5x, and that's the key. Okay, so you've got part of this function, just that part there, not the power 9 as well, with its derivative alongside. And you always let the function that was differentiated be u. Okay, so let's go. This is the substitution I'm making. Key, let u be the function that was differentiated. Okay, let's see what happens now. These three words are the key. Everything must go. So that's got to go. That is u. I've let u be equal to 3x squared plus 5x. I then see I've got 6x plus 5 dx alongside. Well, here we go, 6x plus 5 dx. That's got to go as well. So watch what we do. Let's differentiate this. You get du by dx equals 6x plus 5. Let's try and set up 6x plus 5 dx. Okay, we can do it by imagining this is a fraction, du by dx. It isn't really a fraction, it's an operator, but this works for practical reasons. So you can regard it as being a fraction. The dx comes to the other side. Now this as an operator works just like the du by dx as an operator. That's the key. Okay, you're treating it like a fraction just to help you with the manipulation. All right, so that 6x plus 5 is going to go in place of that 6x plus 5 dx there, and we're going to call it du. That's how I got the du, and you know how I got the u to the 9th. That's the u part there, 3x squared plus 5x. Now I've created a nice easy integral with respect to a new variable. Let's integrate u to the 9th, and you'll get u to the 10 over 10 plus c. I'm finished. All I need to do is substitute back. What was u? U was 3x squared plus 5x. Stick it in place of the u there, and there it is. 1 over 10, that's the divide by 10 there, and there's the u, 3x squared plus 5x to the 10, and you are done. All right? Okay. We can check by differentiation if you want to, and if you do, you just go 10 comes in front, that 10 will come in front. 10 over 10 is 1, and reduce that power by 1 to get 9. And then don't forget to differentiate the 3x squared plus 5x to get the 6x plus 5. And that's exactly what the question was. This was our question. Okay, let's go further. Let's do a definite integral this time. So look at the next example. Okay, I've got the integral of cos x sine cubed x. Now, which part is the derivative of which part? If you differentiate cos x, you certainly don't get sine cubed x. If I differentiate sine cubed x, I don't get cos x. But if I differentiate sine x, just part of that function, I'll get cos x. So there's the clue. But if you rewrite this like sine x to the power 3, we're going to let that sine x there be equal to u. Okay, that's the key. There it is there. U is sine x. Du by dx is cos x. Remember those three words? Everything must go. So there's this sine cubed x there, sine cubed x. That's u cubed. Try and set up the cos x dx. Here it is here. Differentiate sine x with respect to x. You get cos x. Bring the dx across. Bring that dx across here, you'll get du equals cos x dx. So I've set up cos x dx to be replaced by du. And there it is. there. Okay. Now, how do you integrate u cubed? Correct. U to the 4 upon 4. This isn't a definite integral after all. The next one will be. Okay. And now substitute back. U is simply sine. So sine to the 4th x over 4 plus c. Okay. Now we're going to try a definite integral. Right. So here we have I equals the definite integral from 1 to 2 of this function here. Firstly, I want you to realize that these are x values. X equals 2, x equals 1. And I've made that point here. X equals 2, x equals 1. All right. Now remember the three words. Everything must go. Let's study it first. We notice that the 3x squared plus x on the bottom, if you differentiate that, you will get 6x plus 1, which is on the top. So I've noted that here. So we know what u is going to be. U is going to be the thing that was differentiated. So let u be equal to 3x squared plus x. Differentiate that, you get du dx equals 6x plus 1. I must try and set up the 6x plus 1 dx. So from here, let's bring the dx across, and we'll get 6x plus 1 dx equals du. All right, so I'm ready for that part there. Okay, but like I said, everything's got to go. These ones, that 1 and that 2 also has to go. Okay, so let's take a look. If x equals 1, then what is u? Back here, u is 3 times 1 squared plus 1. There's what u is. So there's 3 times 1 squared plus 1. You'll get 4. And if x equals 2, I substitute it into there, and we'll get 3 times 2 squared plus 1, which is 13. Okay, now what this means is that I don't have to substitute back. And I've made that comment here. Okay, we need to get the limits changed as well. And then there's no need to substitute back. Only for definite integrals do we need to substitute back. Let's give that a big tick. Okay, let's do the substitution. Well, 1 is getting replaced by 4. So there's the 4 there for the 1. The other one is going to be placed by 13. Okay, x equals 2. And let's take a look up top here. The 6x plus 1 dx will become du. And there's the 6x plus 1 dx was placed by du. It's told you there, that's 6x plus 1 dx, as I've mentioned here. And then u is on the bottom. So this du over u is exactly the same as the integral of 1 upon u du. Okay, can you remember how to integrate 1 upon u du? Correct. It's ln x. Okay, ln u in this case, sorry, ln u. So there's the ln absolute value of u, and there's my limits 4 and 13. Substitute the 13 in, you'll get ln 13, then the 4 ln 4, and that's the same as ln 13 divided by 4. Examine all of that, make sure you're happy. Right, so we have quite a few integrations of substitution. Look at this next one. Again, it's the integral of a product, x squared times x minus 1 to the 7. But this time, neither of them is the derivative of the other. So it's not the chain rule backwards. It's just an ease the algebra type question. Now, you can multiply this bracket out 7 times if you want, but I don't think that's going to be a very easy way of doing it. Okay, you could do that or use the binomial theorem. Rather, let's make a substitution. I'm going to let u be equal to the x minus 7, and I've made that note over here. Now remember the three words. Everything must go. So what will x squared be if that's u minus 7? Well, let's take it slowly. Firstly, what will x be? Well, if u is x minus 7, then bring the minus 7 across, and you'll get x equals u plus 7. So now I know what x squared will be. That'll be u plus 7 all squared. Also, I need the dx to go as well. There's the dx there. Differentiate this, you'll get du dx equals 1. Isolate the dx by bringing it across to the other side. And there it is, dx is du. Everything must go. So that x squared becomes u plus 7 all squared. The x minus 7 to the power 7 becomes u to the power 7, and the dx becomes du. And I've made those substitutions from line 2, 1, and 3 respectively. Everybody make sure you're happy with that step, how the substitution has taken place. You should not see an x in sight there. All of them should be something with respect to u. All right, check it out. Right, I'm now going to expand the x plus 2 all squared. That's a hell of a lot easier than expanding the power 7. And you'll get u squared plus 14u plus 49 times u to the 7, which is that u to the 7 there. So u to the 7 will be multiplied by u squared. You'll get u to the 9 by adding the powers, and 14u to the 8 and 49u to the 7 respectively. I am ready to integrate. The integral of u to the 9 is u to the 10 over 10. The integral of 14u to the 8, add 1 to the power, u to the 9, divide by the 9. And finally, 49, u to the 8 over 8. All we need to do is substitute back, putting u equals x minus 7, and I'll get x minus 7 to the 10 over 10. Here I'm going to get 14 over 9. There's your 14 over 9 there. And that's times on the top by x minus 7 to the 9. And the last one in a similar way. You should be happy with that. Check it out. Okay, last example. This is going to help us in the last example. A divided by root a is a divided by a to the half. You're going to subtract the powers. 1 take away a half is 1 take away a half. That's a to the half. What about 1 over root a? Well, root a is a to the half. 1 can be regarded as a to the power 0. So I'll get 0 take away a half, and that's how I got a to the minus a half there. That is going to help us in our next example. Okay, this time I have the integral of a quotient, something divided by something. Okay, very similar to what I had in the previous example. It's still can be regarded as the product as something times 1 over something. And I've got the square root of x plus 1 on the bottom, and it just looks a little bit tricky. So what am I going to do? Let's make a substitution with u equals x plus 1. I've got it there. I need to find what the x is. Okay, so bring the 1 across, you'll get u minus 1. I need to find out what dx is. So differentiate this, you'll get 1. Bring the dx across, you've got du equals dx. I'm ready to, everything must go. Okay, so there's the x, it's u minus 1. The square root of x plus 1 is the square root of u. Dx is du. Let's give that a big green tick. You should be happy with that. Okay, now the bottom is u to the half. There it is there. I'm dividing by a single term, so I divide each of the top terms by a single term. I have that there on the next line. Now you should remember how to do this. See if you can simplify each of those fractions for me before you listen to what I've got to say. All right. Yes, you should have got u to the half here and u to the minus a half there. Would you like to try and integrate those? Give it a go. Let's see what happens. Okay, so I add 1 to the power. I'll get 1.5, which is 3 over 2. There it is there. Just go 1 over 2 plus 2 over 2, which is 3 over 2. Divide by 3 upon 2. So I must flip that 3 upon 2 over and multiply by it. 2/3 u to the 3 upon 2. After a while, you should be able to do that in one step. Add 1 to that minus a half. You'll get plus a half. Divide by plus a half. Means the same as multiplying by 2 over 1. You get 2u to the half. All you need to do now is substitute back and put the x plus 1 in place of the u, keep the 2/3 and the 2, and you get your final line there.